So now that we practiced finding GCF and you're rock stars at it, now we can practice factoring using GCF. And this basically has 3 steps to it, and I hope you wrote your 3 steps down. Your first step is to identify the GCF, then we're going to divide the GCF, and finally we're going to mentally check to make sure that we did it right. So let's get started. I'm again on page 390. We're going to do examples in the second column, and we're going to start with number 20. So number 20's question says x squared plus 5x. So the first thing that I want to do is identify the GCF. So when I find the GCF, the first thing I want to do is look and see what's the biggest number that divides into all terms. Unfortunately, there's no numbers other than the 5, so we don't have to worry about the number part. The other piece we have to be concerned about is the variables. So they each have an x here, and because they each have an x, we're going to pick the lower one. So this one has 2 x's to give, but this one only has 1 x to give. So our GCF is actually x. It's the smaller variable. Once we do that, the second step is that we want to divide. So we get the GCF, then we divide. By the way, when we do this, the GCF goes on the outside of the parentheses like that. Okay, so this goes out front. Then we divide. When we divide, we take our x squared, which is our first term, and divide it by that GCF. Then we take our 5x and divide it by that GCF. Okay, now don't forget your division rules. When you divide, you're going to divide the numbers, but we don't have any there. We're going to keep the base, and we're going to subtract the exponents. So remember, this is really x to the first. So x squared divided x to the first, 2 take away 1 is going to give us x. Here, the 5 divided by 1 is 5. And this is x to the first over x to the first. And remember that you subtract these exponents and they cancel because you end up with 0. And this value right here goes on the inside. That's step 2. So find the GCF, that goes outside. Divide it by the problem. This goes inside. And our last step is to mentally check. Now, mentally check means I'm literally doing this in my brain. X times x gives me x squared. That's what I started with. And then x times 5 gives me 5x. And that's what I started with. So boom, I know this is correct. So there's my mental check. And I'm done with that factoring problem. I'm factoring GCF by finding the GCF, then dividing it. Whatever you get when you divide goes back inside the parentheses. Let's take a look at the next one, which is 23. For 23, the question is x to the third plus 6x squared. Again, I don't know what's going on with my camera today. Again, what we're doing is we're looking for GCF. We still don't have 2 numbers, so we don't have to worry about those factors. We're looking at variables. This has x to the third, so that's x times x times x. That's 3 of them. This says x squared. That's x times x. That's 2 of them. We want the smaller of the exponents. Then we're going to take our problem, x to the third plus 6x squared, and we are going to divide by that GCF. All right, this is our division step. Don't forget that we have to keep the base and subtract the exponents. 6 comes down. When I subtract these, they cancel out. 2 minus 2 is 0. So I just get x plus 6. Last, I'm going to just mentally check x squared times x. That does give me x to the third. X squared times 6 gives me 6x squared. Does this look like this? Indeed it does. So this is the correct answer. All right. So that's some basic ones. We're going to go ahead and keep working down that second column to get you prepared for this assignment. We are on number 26. That's our third one. 26's problem is 5x to the fifth plus sign 10x to the third. Here we go. I'm doing GCF first. When I do the GCF, I want to find the biggest number that divides into 5 and 10. My factors for 5 are 1 times 5. Does 10 divide by 5 okay? Yes, it does. So this is my GCF. I also need to look at my x's. This one says 5 of them. This one says 3 of them. And we're choosing the lower one. So our GCF for this whole problem is 5x to the third. 5 comes from the fact that the 5 divides into both of those is the biggest one. And x to the third because that's the smaller exponent that both of them are able to give. So 5x to the third goes on the outside of parentheses. The second step is to divide. When I divide, I'm going to take my problem that I got, which is 5x to the fifth plus 10x to the third, and I'm literally dividing by that GCF. Now, this is the first one that we've done where we are doing both numbers and variables. You divide the numbers. So 5 divided by 5 is 1. That cancels, becomes a 1. Subtract the exponents. That's x squared. 5 take away 3 is 2. This one, 10 divided by 5. We're dividing these. That's going to give us 2. And 3 take away 3 is 0. So these cancel. So inside the parentheses up here is x squared plus 2. Now I just have to double check my math. 5x to the third times x squared. When I distribute that, I should get 5x to the fifth, which it is. And then when I do 5x to the third times 2, 5 times 2 is 10. This should be 10x to the third, and it is. Boom. I did it right. This is my answer. I'm literally checking it with distributive property to make sure that it factors correctly. Whatever I do when I distribute should take me right back to my original problem. That's why factoring is really like reverse distributive property. 29 looks a little aggressive. It really isn't, but it looks it. Let's check it out. 29 says 17x to the fifth, y to the third, plus sign 34, x to the third, y squared, plus sign 51, x, y. Wow, that's a big one. And what the first thing you should notice is that all of them have x's and all of them have y's. So no matter what, you're doing a greatest common factor. All right, we want to do greatest common factor as our first round of defense for factoring. That's the first thing we're going to look for. But I actually want to take a look at the lowest coefficient, which is 17. And I'm going to write my factors for 17. But 17 is prime. So the only factors are 1 and 17. So all I have to check is, can 34 divide by 17? And 34 divided by 17 is 2, so yes. And does 51 divide by 17? 51 divided by 17 is 3, so yes. So because 17 is the biggest factor in this one, and it divides into this one, and it divides into this one, 17 is my GCF. Now I just have to pick apart my x's and my y's. I'm going to start with x's. There's 5 here, 3 here, 1 here. I want the lowest one, so I want x. For y's, I have 3, 2, and 1 of them. Again, I want the lowest one because I want the one that each term can give equally. And this 51 can only give one each. So that's what it is. So when I do my GCF, 17xy comes outside the parentheses. Now I divide. This is my divide step. I've got to divide all this by my GCF. So I'm going to take 17x to the 5th, y to the 3rd, 34x to the 3rd, y squared, and 51xy. And I'm dividing each of them by my GCF, which is 17xy. Remember when we divide that we divide the numbers. So 17 divided by 17 becomes a 1. I'm going to subtract these exponents. So this is 5 take away 1, which is x to the 4th. This is 3 take away 1, which is y squared. There's my first term. This is a positive 34, so, oops. Look, I got a little crazy. I'm going to put the 1s in now. Okay. So then I'm going to do a positive 34 divided by a positive 17. We already said that that was 2. We're dividing that, you get 2. Then you subtract the exponents, I get x squared. Subtract the exponents, I get y to the 1st. Last one, I got 51. I'm dividing by 17. I did that. I got 3. This is 1 take away 1. Those cancel. And 1 take away 1. Those cancel. So this is what goes inside the parentheses. The division, whatever you get for your outcome for your division goes on the inside. So I have x to the 4th y squared plus 2x squared y to the 1st plus 3. Now I just need to distribute. This is my third step. I want to make sure that I got all my stuff right. So here, I'm going to do 17 is my constant. And this is x to the 4th times x. So that's x to the 5th altogether. Because remember, when you're multiplying, you add them. So this is 1 of them and 4 of them. That makes 5 of them. And 2 and 1 make 3. We good so far? Yes. Now 17 times 2 is 34. X, there's 1 here and 2 here. That makes 3 of them. And 1 here and 1 here makes y squared. Does that work? Yep. And then 17 times 3 is 51. And the only thing that tags along is that x and y. Does that work? Yep. So because I double checked it, and I did it mentally, I just, multiplied it out, made sure that they matched. I know that that's my correct answer. Sometimes we find our mistakes when we multiply it back out. Like, oh, snap, that's not even it. We got one more of this type, and then we're done with this guy. And we'll move on to the next one. So 32 is our last one. This one says 5x to the 5th plus 10x squared minus 8x. Interesting. So what we're going to do is start with GCF. Remember, when we're doing GCF, we take the smallest factor, the smallest one, and we break it down. So 5, 10, and 8, between those, 5 is the smallest. So we're going to do 1 times 5. And I have to see if 5 is divisible, or if these numbers are divisible by 5. Well, can 10 divide by 5? Yes. Can 8 divide by 5? No. So it's not 5. If it's not 5, the only other thing it can be is 1. So my GCF is 1. Let's look at variables. I've got x to the 5th, so there's 5 x's here. I have x squared, so there's 2 x's here. And I have a single x to the 1st, so that's 1 x here. Remember, we want the lowest one. So our GCF is really just 1x or x. Put it on the outside of the parentheses. Now we have to divide. This is our last step of division. We are going to take our problem, 5x to the 5th plus 10x squared minus 8x, and we are literally dividing it by 1x. Let's see what we get. 5 divided by 1 is 5. Subtract your exponents. You get x to the 4th. 10 divided by 1 is 10. Subtract your exponents. You get x to the 1st. Negative 8 divided by 1 is negative 8. Subtract your exponents. You get 0, so this cancels. So this is the polynomial that goes on the inside. Last step, just double checking by doing a mental math. X times 5x to the 4th. Remember, we're adding our exponents. That should give us 5x to the 5th, and it does. 10x times x is 10x squared, and it does. Negative 8 times x is negative 8x, and it does. So this is my final answer. I did my mental math. I checked it out, and this works. When I distribute it, I get back what I started with. This is how you factor out a GCF from any polynomial.